Hey guys, it's Rez. All right, so our last part of Unit 1, we're really going to look at how ecosystems and living things respond to changes in their environments. And I wanted to give you guys a little bit of background. I'm going to fly through these next slides. Please know that these come up again when we really start looking at natural selection and adaptation and populations. But I wanted you to be aware that when we're talking about living things, they really can fall into two categories of living things. Some species are what we call specialists. And what that means is that they have a really kind of narrow range of what they can eat and where they can live. We say they have a small range of tolerance. So they have kind of a very specific niche in which they live. This leads them to be kind of vulnerable because if, for example, like the panda, who only eat bamboo, if something happens to the bamboo, they've lost their only food source and they don't have anything else they can fall back on. They tend to have less ability to adapt to changes that happen. So specialists are the ones that struggle when we have changes or massive changes in ecosystems. We also have generalist species. So generalists, like it sounds, kind of have a much broader range of tolerance. They have a broader niche. They typically eat many food sources. They're very adaptable. They might be able to live in multiple places. These are things that are going to be a little bit more resilient when we have ecosystem disturbances. The next slide is really only to show you that specialists and generalists are a range. So not all living things are going to be only a specialist or only a generalist. Sometimes they fall somewhere in the middle. Sometimes some are like slightly specialized, but they're not all the way over, into that specialist category. So just be aware when we talk about these that it is a range. Going back to the idea of tolerance. So every living thing has what we call an ecological range of tolerance. So the technical definition of that is it's a range of conditions, and it can be anything from temperature to like the salinity of the water that they live, the pH, the sunlight. It's those range of conditions that they can endure before injury or death results. Every living thing as a species has a range of tolerance that is kind of specifically adapted to their individual environment. However, individual organisms will also have their own slightly different, sometimes, range of tolerance. So, for example, let's look at salmon. Salmon as a species have a basic range of tolerance between 6 to 22 degrees Celsius in their water temperature. Sometimes individual salmon can survive a little bit warmer. So maybe they can survive up to like 26, 27 degree Celsius water. So they have a slightly different range of tolerance than the average. That's just a normal genetic variation. But if there is an environmental pressure, in this case, right, we have increasing ocean temperatures, we may see that some of those salmon are the ones that are better able to survive and reproduce. I actually saw a really cool, I think it was on 60 Minutes recently, where they were looking at coral and how some coral are very similar to this. Individual coral can have more of a genetic ability to withstand rising ocean temperatures, and how they're actually working on genetic testing coral, harvesting the ones that are better able to survive in warmer waters, and creating man-made coral reefs so that they can repopulate them with that type of coral. So kind of cool. And then I just showed you a couple. This is the idea of what we were just talking about, that as a species, they have a general one, but sometimes you get slightly different range of tolerances based on their own genetics. All right. So back to this range of tolerance. When we look at range of tolerance, and we're going to do a big graphing activity with this in class, but basically it looks like a bell curve. The optimal range in the middle, that's where organisms are going to thrive. That's where they're growing, they're reproducing, they're living their best life, right? It's in that optimum range. That's also their preferred niche. That's where they prefer to be. Now, next to that, on either end, you have this zone of physiological stress. So this is where the organism's alive, but it has something, some kind of negative result of being slightly outside where it wants to be. Sometimes that's infertility. Sometimes it's just their decreased activity or reproduction, or maybe they're not growing as much, but something's going on. And then on the outsides of that, you have your zone of intolerance. So the zone of intolerance, this is where like the organism can't survive there. It's not going to make it. Sometimes that's because of thermal shock, or I give you some examples here. We call that an unavailable niche. That's a place where they cannot live. So ideally, we want things in optimal range. Sometimes disturbances may push living things into that zone of physiological stress. They're usually okay as long as they're not there for too long. If they enter into that zone of intolerance, though, because of a disturbance, that's where we're going to see death happen. All right. I'm going to skip over these FRQ writing tips. I have them in here because there's an FRQ on this almost every year on the AP test. It's worth taking a peek. Like I said, I'm flying through them here, but it's worth taking a peek if you have a chance. All right. So let's look at some natural disturbances to ecosystems. Now, we're not talking man-made. We're talking natural. So it's any event that's happening without our interference that's going to disrupt the structure and or function of an ecosystem. These are going to be natural disasters, right? Tornadoes, hurricanes, forest fires, droughts, asteroids in some cases. Okay. Now, we typically think that humans are the biggest disruptors of the ecosystem, and that's because of the world we live in currently in this era that we're in. But natural disturbances can often be even greater than human disturbances, right? Think of the asteroid that killed the dinosaurs. That was a pretty big disturbance, and we had nothing to do with that because we weren't here. So these disturbances can occur on certain time frames. So periodic time frames, these are regular frequencies. These are predictable. We know they're going to happen. Think of these as like rainy and dry seasons, right? Or like the monsoon seasons that we see, like where it's, again, rainy seasons in certain parts and dry in others. Those are periodic. Then we have episodic. Now, these are things like hurricane season. We know hurricane season is going to happen every year. We know the months that it's active, but we don't necessarily know, well, there's going to be one hurricane every week, right? The frequency that those hurricanes occur is irregular, but it's kind of, we know that they're going to happen occasionally. Same with like a forest fires. Typically there's a season for them, right? And then we have random. These are things that happen with no frequency, no regular frequency. So volcanoes, again, they happen when they happen. Earthquakes, asteroids, things like that. Okay, so this leads us into talking about natural climate change. We have a whole unit that looks at anthropogenic climate change, so human caused, but Earth's climate changes for lots of reasons throughout the course of history, right? If you look at, I think this picture is a little exaggerated, but Earth's orbit is slightly eccentric. So there are times when we are slightly closer to the Earth than others, right? In our, like, again, we're talking big geologic history. Our tilt will also slightly shift, so that can affect it. So we have these things that cause little mini ice ages and warmer periods, and we can see that in the graph here throughout time. Okay. We're, again, slightly different where you look like at the end where we've got this 400 parts per million spike. But you can see, again, regular patterns of warming and cooling throughout Earth's history. That's natural climate change. Because of this, sea level has also varied. As it gets warmer, we're going to have glacial ice melt. As water warms, it expands. So we see sea levels rise and fall. Again, that's normal. We'll look at how, again, anthropogenic has pushed that a little bit, but we've seen sea level changes forever. Now, when we have these environmental changes, they're going to result in widespread habitat change and loss, right? For example, rising sea levels are going to really affect coastal and estuary habitats, which are super kind of fragile ecosystems anyways. So if you look at like the current prediction, right, or the current situation for where sea level is, if it rises too much, now you're infringing on some of, like, those are supposed to be mangroves, I think, like those mangroves forests and the things that were there, you're shifting all of that back. Okay? So often with these, we have migration. Now, living things migrate anyways, right? Based on those very regular disturbances that we see. Wildebeest migrate every year to follow the rains. Actually, a lot of things in Africa migrate every year to follow the rains. There's a picture. But we also see migration in response to kind of some of these larger scale issues. So we're starting to see ocean species moving further north as the water temperature warms. We're starting to see actually lionfish, which we're going to talk about with invasive species, starting to make their way up here because the water is warmer. We're also seeing birds start to migrate sooner. Hatchlings are kind of hatching earlier as our climate warms, and we're actually starting, we can see that, we can measure that difference. So this chart is showing you here kind of in 1980 versus today where those kind of things fall. Okay. So your FRQ is here. You're going to look at the relationship between latitude and change in the first leaf date depicted in the graph and explain why you think that exists. The graph is here if you need to see it. I think I put it on your FRQ too. Happy writing. We'll talk about this when you get in, and stay tuned for part 2.